So as I mentioned, we have three motors. We have BLDC motor, induction motor, and synchronous motor. So we'll start with the BLDC motor. So for BLDC motor, the best way is to start from this. Okay, just a minute. Okay, right. So this is again, although this is for a 3 kilowatt motor. Okay, right. So for a 3 kilowatt motor, we have this specification sheet where we have the whole data of. So on one side we have power input over here. Okay. So on one side we have power input. Okay, right. So we have voltage, current, and input, and on the other side we have the output parameters, which is torque, RPM, and power output. And on the basis of that, we have the efficiency, right? So the efficiency is also given on the basis of that, right? So that is simple: power in upon power out, right? So that is your efficiency. Now you can see that, as I mentioned, so over here we have 32% efficiency, but down below here you have 90% efficiency, right? So BLDC motor has a wide range of efficiency, right? No, but we are not concerned about this. We are more what I have opened this PDF to show you this graph. So take a look at this graph. This is clearly visible to you all, right? Whatever is written in this.
Yes, sir.
Okay, so take a look at this graph and tell me what you are able to understand. Okay, see, we have few parameters over here. We have peak power. Just a minute. Okay, so we have peak power, right? Then we have peak torque, right? We have peak torque, peak power. Then we have rated power and rated torque. Okay, we have four terms over here and the rated speed, right? So we have these five terms over here. Okay, so for this BLDC, so let's start with peak power.
Maximum power controller can supply.
Okay, okay, it's not controller can supply, it's what motor can deliver. Okay, because that power is after the losses,
Yes, sir. Yes, sir.
right? क्योंकि controller तो उससे ज़्यादा दे ही रहा है. So we have peak power. So peak power is basically uh, maximum power the motor can deliver. Okay. Now for this the criteria is t is equal to 30 seconds. Okay. So usually we want like usually it is when we are measuring, like we know that the motor testing is done, right? So while doing the testing we calculate the peak power for the maximum power the motor can supply for 30 seconds. Okay, but under operational condition we take this time to be 10 seconds. Like it is recommended that your motor should not operate at peak power for more than 10 seconds. Okay, yes. So rated power is power delivered during normal operation. Okay, so rated power is again the maximum power delivered for continuous operation. Okay, maximum power delivered for continuous operation. Rated power is maximum power delivered for continuous operation, right? And usually for this, so while motor testing you might come across a term. If you study when you will study about the motor testing and all, so you might come across a term which is maximum 30 minutes power. Okay, So that is also termed as rated power. Okay. So for this rated power, we take maximum power delivered for continuous operation, and to while testing we take that time to be the operational time to be 30 minutes. Okay, we take that operational time to be 30 minutes. So maximum power your motor can deliver continuously for 30 minutes, that is considered as rated power. Clear?
Yes, sir.
Okay, right. Then we have peak torque, right? So peak torque is what? Maximum torque delivered by motor, right? And in case of BLDC, peak torque is equal to initial torque, right? Peak torque and initial torques are same. Okay, is it clear?
Yes, sir.
Right. So as we saw in this graph, if I come back to this graph, so initially for you can say for this initial range of operation, for some time you will have a constant peak torque, right? And so this actually this region, this whole region is also known as constant torque region. Okay, this initial region where you have a constant torque, so that is also known as constant torque region. Okay, so we have peak torque is equal to initial torque. Then what about rated torque? What will be rated torque? What will be rated torque? Torque delivered at rated power. Okay, rated torque is actually torque delivered at rated power. Okay, and similarly, see, rated RPM is RPM at rated power. Okay, and rated torque is the torque delivered at rated RPM. Okay, right. And then apart from this, you have peak power, peak and rated power and peak torque. Okay, so these five are the quantities that we have. Right. So is this clear?
Yes, sir.
भाई ये क्या हुआ? ये क्या हुआ? वाईफाई बंद हो गया क्या? Okay. I'm audible now?
Yes, sir.
Hello?
Yes, sir. Yes, sir.
Hello?
Yes, sir.
Yes, sir. You're
Okay.
audible, sir.
Okay. Okay. So we have these five parameters. So okay, right. So this was our BLDC motor, right? So I'll just this a mini version of this graph. So over in this, so we have torque something like this. Okay, and we have power something like this, right? For BLDC motor. Okay, right. Now for BLDC motor, as we know that this is a DC operational motor, right? So it is using DC source, right? So BLDC motor is using DC source, right? So over here now, this is the torque and power of the motor, right? Now for this motor, if you vary voltage and current, okay, right? If you vary voltage and current, you will be able to vary the torque, right? So I'll just re-explain this to you. So See, okay. See, we know that the motor works on like by electromagnetic interaction. By electromagnetic interaction, the motor will rotate, right? Because there is a magnet inside and then there is an electromagnet, and due to their interaction the motor will rotate, right? And so if you have stronger magnetic field, okay, so stronger magnetic field will give you stronger repulsion force, right, in order to rotate the motor, right? And this stronger repulsion force will give you strong or more torque, right? So if you have a stronger magnetic field, that means the force acted on the rotor will be higher, and that means the torque will be more, right? Now how can you get that strong magnetic field? So there are two methods. Either you, when we are using permanent magnet, right, so either you use permanent magnet which already has a stronger magnetic field, right, and then while operation, while the motor is running, so during that time you can manipulate voltage and current. Basically you can increase the voltage or current, okay. We don't increase both of them simultaneously. Either you will increase the voltage or you will increase the current, okay. So if you increase voltage or current, the magnetic field will also increase, right? The magnetic field intensity will increase, right? And due to that you will have a stronger repulsion force and then the strong or more torque. Is this clear?
Yes, sir.
Okay. So in short, if you manipulate the voltage or current, you can easily manipulate the torque, right? Similarly, if you manipulate, now in case of BLDC motor, BLDC motor works on like works by sending DC pulses, okay. In BLDC motor we send DC pulses, right? Because DC, see, for motor to work you need varying magnetic field, right? You need varying magnetic field. Now a DC current is constant, like DC current will always be constant in value, right? So you don't have varying magnetic field over here. So in that case what we'll do, we will give pulses of DC current. So immediately the current will spike, then come to zero, then spike, and then come to zero. So accordingly the magnetic field will in, uh, increase or decrease, right? So it will be like this. So I'll just draw a broad graph. So for example, the DC pulse is like this. For example, if this is the DC pulse, right? So magnetic field will be like this. Like the magnetic field value will be like this. It will increase and then remain and then it will decrease, right? So in case of BLDC motor, we provide pulses, okay. Now and thus if you, so that thus the method we use is pulse width modulation. Pulse width modulation, okay, or PWM, right? So if you increase the number of pulses, you can increase the RPM. So you have pulse width modulation and all, right? So basically for motor, now this is why in case of motor usually the single speed gearbox is used, okay, because unlike engine where we are using multi-speed gearbox to gain high torque in the initial and then the constant power graph, okay, right? Over here, in motor you have the ability for same RPM. Okay, for same RPM, you can instantly vary the torque by keeping the RPM constant, because both of these parameters are controlled by, like both of these quantities are controlled by different parameters basically, right? So RPM is controlled by pulses, and torque is controlled by voltage or current. Okay, rest, if like you can ask, if you can ask in detail about how exactly or how much this variation can be done in next week when the next faculty will be there, so to teach you about the motor controller, right? So there you can ask him about what, how much variation you can do and everything, like there he will tell you about it. Okay, he also has a very good knowledge in this section. Okay, right? So but yeah, okay, so this is, so that is why in case of motor, you usually the single gearbox does the job. Okay, now similarly if you come to look at the induction motor, so for induction motor the graph is something like this. We have RPM, and then we have torque, right? So the graph will be like this. Okay, so initially you will have a starting torque, right? Then you will reach up, so it will initially it will start with some value, then it will start decreasing. Okay, and till you reach to a point known as pull up torque. Okay, right, and then it will start increasing and it will reach the breaking, sorry, it will reach the point of breakaway torque, not breaking, breakaway torque. Okay, so this is how it goes in case of induction motor, right? So you have starting torque, pull up torque, and breakaway torque, right? Starting torque is in starting, pull up torque is the minimum torque that your motor will provide, okay, under operating region. So usually for induction motor this is the operating region. Okay, and then you have breakaway torque, right? So it will increase, and because in the starting, as the name suggests, induction motor, right? I'll just write this is for induction motor. Okay, so induction motor works on the principle of induction, right? So you will have a rotating magnetic field. That magnetic field will induce current into the rotor, and due to which the rotor will generate its own magnetic field and then start following the stator magnetic field. Okay, so it is a self-start motor in itself. Okay, this motor is self-start. Okay, so the major advantage of having an induction motor is it is self-start. Okay, it doesn't matter at what RPM you, like how much current or frequency, whatever it is you want to provide it, it can start itself because it works on the principle of induction, right? But the issue is that initially it will not have that much good of initial torque, right? So that is one of the reasons why induction motor was induction motor went out of fashion. Okay, right, because it doesn't have that much good initial torque. So you can, for to understand this, you can take the example of ceiling fan. Ceiling fan are usually like, ceiling fans are induction motor. Okay, so you can see that when you switch on the fan will slowly start and then take up speed, right? Okay, so because it is an induction motor, the fan in your laptop, CPU, right, these are BLDC motor. Okay, so immediately as soon as it starts, you can see that immediately it is rotating at high RPM, right? Because these are BLDC motor, and ceiling fan takes time to start because that is induction motor. Okay, and then you have the third parameter. So third type of motor, which is PMSM motor, right? or synchronous motor. Now for synchronous motor, the same thing, the torque graph is there and then the RPM is there, right? Now for synchronous motor, the graph is more like this. Okay, right. The synchronous motor, the graph is more like this, right? So you can see that it has a very high, it has a initial torque, but that torque will decrease as the RPM increases, but that decrease is parabolic in nature. Okay, that torque reduction is parabolic in nature, right? So due to this, you can see that initially, like if you compare this with BLDC motor, right? So BLDC motor has something like this. Okay, BLDC motor will be something like this, right? And induction motor. So this shaded area, this graph is the extra power that you can gain in case of PMSM motor, right? And that is why for four-wheelers, that this is also one of the reasons why for four-wheelers you can see that induction motor is preferred more than BLDC motor. Okay, right? So is this clear?
Yes, sir.
Okay. Now because both of them are AC motors, right? Both induction motor and PMSM motors are AC motor. So over here, voltage and current is used for torque. Okay, you can vary voltage and current to vary the torque. And for RPM, over here we vary the frequency, AC frequency. So if you vary the frequency, you can vary the RPM, right? Clear?
Yes, sir.
Okay. So is there any more question? So okay, okay, right. So that is why now now it is clear to you, right? So why we are exactly using the single speed gearbox in motors, right? And why multi-speed gearbox are being used in engine. This is clear, right? Okay. So now the next question is, so now not the question, now coming to the topic of the single speed and multi-speed gearbox. So in terms of EV, now we'll be talking. Okay. Now for EV, okay, for EV, single speed gearbox is lightweight. Okay. And it is cheaper, right? So single speed gearbox is lightweight and it is cheaper, right? And as well as single speed gearbox is possible because the motor drive or control is mostly done by controller, right? So from controllers end you can mostly do the motor drive or control, right? So and because in single speed gearbox is cheaper and it is because obviously it is small size, so it will be lightweight. So that is why single speed gearbox is being used. Okay, but then why do Porsche and Formula E, these teams, they are using multi-speed gearbox? See, the major advantage of multi-speed gearbox, like if we talk about multi-speed gearbox, okay, so the major advantage is improvement in range of the vehicle. Okay, so we saw about that example, right? For 100 kmph, second gear, third gear, and fourth gear, right? We
Yes,
saw
sir.
about this example. Sorry, array. So yeah, so we saw about this example, right? Second, third, and fourth gear, right? So using the same logic, okay. So thus it is clear that if you are using multi-speed gearbox, so for same amount of voltage and current consumed, okay, or for same amount of power and torque being delivered by the motor, if you keep on shifting the gear, like from first gear to second gear to third gear, you might be able to travel more speed, right, for the same amount of power consumed, as similar to engine, where for same amount of fuel consumed you can travel at higher speed by shifting the gear ratios, right? So there was a research paper which claimed that, like they did the mathematical the uh, te- basically a team of researchers, students basically, from a university in Switzerland. So they did this research, and like on model based research, and they concluded that the multi-speed gearbox will provide an increase in range, improvement in range for the same battery pack, uh, right? And then it was later on practically verified. So if you have two speed gearbox, okay, that means first gear and second gear, you can increase the range by 6%. Okay, if you have three speed gearbox, okay, first, second, and third gear, you can increase the range by 10 to 13%. Okay, and if you have four speed gearbox, so you can increase the range by 20 to 23%. Okay, so that is that, right? So if you are able to shift the gearbox or the gear ratio, you might be able to increase the range, but that will be a costlier setup. The cost will increase obviously, right? And the weight will also increase, right? So these are the two major reasons why most of the manufacturers are not yet opting for multi-speed gearbox, right?